Hello guys and welcome back to class. We have a question on the board and it's Bernoulli's equation. Bernoulli equation is an extension of linear ODE. Extension of linear ODE is just a little bit different from linear ODE, which means we are going to be looking for integrating factor. But before that, it doesn't look like a linear first, so we have to express it and bring it to become like a linear ODE. Then we can look for the integrating factor, multiply, and then solve and get what we are asked to do. So this is the question in the board. So we should solve this, and it's a Bernoulli question. So what do? Now in Bernoulli questions, we have to make this linear. In that case, I will need this to stand alone. So I will divide all through by x. Dividing all through by x, I will have dy dx plus y over x is equal to x squared y to power 6. That's the first step. Then secondly, I will still divide all through by y to power 6 because I have to express it in Bernoulli form. So divide all through by y to power 6, I'll have y to power minus 6 dy dx plus y minus 5 over x is equal to x squared. Good. So at this point now, I'll say let z equal to y to power minus 5. This is minus 5 here. Y to power minus 5. So if I'm differentiating z with respect to x, I'm going to have minus 5y to power minus 6. Then I have dy dx. From this point, I'll just multiply all through by minus 1 over 5, or rather I'll divide by minus 5. So I'm going to have minus 1 over 5 dz by dx is equal to y to power minus 6 dy by dx. So now at this point here, look at this. This whole thing here is what I have here. So in place of this up here, I can put this. Then my y to power minus 5 is equal to z. So I can put this one also here. So imputing now, I'll have minus 1 over 5 dz dx, that's for this one here. Then for this, I'll put my y to power minus 5 is z. So I have plus z over x equal to x squared. So here now, what I'm going to do is, I want to make it a linear ODE. So I'll multiply each of these terms by minus 5. So multiplying this one, I'll have dz by dx minus 5z over x is equal to minus 5x squared. So from this place now, generally we normally have p, q, and the rest. So from this point now, my p now is my p of x is going to my p of z rather. My p of z now is going to be minus 5 over x. So I want to look for my integrating factor. That's why I'm bringing this. I want to look for my integrating factor. So my integrating factor is going to be exponential, the integral of p of z dz. So you see that p of z dz. So p of z is this. So I'm going to be having my integrating factor is going to be exponential, the integral p of z is this. I have minus 5 over x then dx. So my integrating factor from there is going to give me exponential minus 5 is here, ln x. So integrating factor is giving me exponential ln x to power minus 5. This will give me 1. So my integrating factor now is x raised to power minus 5. Now once I've got my integrating factor, I'm going to use the integrating factor to multiply the linear ODE. Remember, if you are doing linear ODE, I'm going to use the integrating factor and multiply the linear ODE. So this is the linear ODE. So multiplying it now, permit me to use this space. Multiplying all this, I'll have x to power minus 5 multiplied by dz by dx minus 5z over x is equal to minus 5x squared multiplied by x raised to the power of minus 5. So if I multiply this, I'm going to have d dx into x raised to the power of minus 5 multiplied by z equals to minus 5 x raised to the power of minus 3. So that's what I'm going to have, minus 5 raised to the power of minus 2. So this side is simple as I'm getting this. Now I will integrate both sides. So integrating this side and integrating this side, this integration sign and this d dx will go. So I'm having x minus 5 dot d dot z is equal to, integrating this now, I'm having minus 5x raised to the power of minus 2 over minus 2. So x raised to the power of minus 5z is going to give me 5 over 2 x raised to the power of minus 2. So it is my z that I'm looking for, right? I'm looking for my z, so I'll just multiply all through by x raised to the power of 5. So if I multiply it by x raised to the power of 5, I have 5 over 2 x raised to the power of 3. Okay, let me add my integrating constant here because it's very necessary. So when you're multiplying by 5, you have this x raised to the power of 5. That's my integrating constant. But I need you to recall something. That's not the end of it. I need to recall something. My z, we said that let z equals to this. So I'm putting this back into this place. So my y to power minus 5 is equal to 5 over 2 x to power 3 plus c x to power 5, and that is what you are looking for. So you see, in Bernoulli you have to express it first to linear, then look for the integrating factor, use the integrating factor and multiply all through the linear, not the Bernoulli now, not the Bernoulli's equation. You use to multiply the linear that you have gotten from the Bernoulli, then get the integrating factor. Do that, and when you finish, you just do your substitution, and you are going to get the answer that you are desiring to get. So by the end of the day, this is what you're going to have. If you have any question, you can ask that on the comment section, and I'll do well to answer you. Until then, I'll see you in the next class.